University. He's the William A. Patterson Distinguished Professor and Director of the Northwestern University Transportation Center, my own alma mater. So 3 cheers for that. And what to say about Hani? Well, if you see his bio on the flyer that goes around, the announcement that goes around, I think of him as a Renaissance person in our field, because pretty much every specialty in our field is listed as a specialty of his. So he makes contributions in just about every area you can imagine. In 1997, he hosted the International Association for Travel Behavior Research Conference at UT Austin, where he was on the faculty at the time. And I don't know if I ever told you this, but one of his students, Karthik Srinivasan, who had gotten his master's at UC Davis, so I knew him, and I was chatting with him at Austin during the conference, and he says, and you know, this travel behavior stuff is just a hobby of Dr. Mahmassani. His real thing is traffic, and he does this travel behavior thing, is dabbling on the side. But you know, he's been a giant in the travel behavior field, former chair of the IATP itself. Many students having won awards and prizes and so on, editor of practically every important journal in transportation, including transportation science and other things. So needs no introduction to most of us, but again, very delighted to have you. And
thank you.
95 slides.
Very much. Thank you. Thinking travel behavior doesn't pay the bills. That's the problem.
Well, tell us about it.
So you gotta have some other way of funding all your students. Anyway, it's a pleasure to be here, and I realize this is already the end of your semester. We're still in the middle of our quarters, so this is very much a busy period for us. But it's, again, it's always nice to come back and see our good friends and colleagues here. I'm going to talk about a topic that you cannot escape hearing about these days in transportation. Autonomous vehicles and connected systems. And as Pat mentioned, there's actually 3 different talks that are kind of bumped together. And I'm going to not spend a lot of time on all the details, but kind of give you a sense of some of the things that we're looking at, and then there'll be references for some of the others. And that's it's 3 things because they're all very important to us. So we kind of motivate things with some definitions. And the 3 main parts is one is you look at adoption, which at this point is a speculative conceptualization, but it seems to be well received whenever I present it, so I thought I'd go through it again. I think Rama's heard it before at the TRB session. And then we'll kind of ask, well, how do we deal with this in our planning models? Because NPOs and agencies and academics are asking, what's there to do to deal with autonomous vehicles? And the substance, though, in terms of the technical work, is looking at the flow implications, particularly the implications of having some of the fleet that is autonomous, some of the fleet that may be connected but not autonomous, and then regular vehicles all traveling together. And the implication is, what is that going to do to the stability? And that's the thing that we're focusing on, the stability of flow. And so there's a lot more material in here of substance in some of the more speculative portions at the beginning. Now, I assume all of you are familiar with NHTSA's levels of automation. So I'm not going to repeat all of those. If you're not familiar with them, essentially it's different degrees of automation, going from none to fully automated, where the car basically could drive itself. It doesn't need you to even be present. But what is you may be less, you may not have heard, is the analogies that our good colleague and friend Anna Kornhauser at Princeton interprets these different levels, because they have to do with who's interested essentially in these levels, and also I like his terminology. So in his view, the 0 level automation is your 55 Chevy, where the driverlessness is 0. The value proposition, that's sort of your base reference, and he's looking at essentially what's the value proposition for an adopter, what's the market force that's driving it, and what might be the societal implication. So if you have one or two functions that are automated, essentially that's, most, certainly upper-end vehicles today already have those. And he views the value of this as being relatively limited. Essentially, insurance industry is interested in getting safer capabilities and so on, but not huge implications. I like his terminology here for 3, whereas the driver has to be there, but a lot of the driving functions are kind of surrendered to the vehicle. He calls it a texting machine. Okay? So essentially, you're in there and you're texting or doing other things, and there's some driverlessness. The value proposition is it liberates you, and it's also much safer. There's a consumer pull, and the whole infotainment industry is pushing there, and that might help sell more cars, and possibly increase VMT. And the interesting part with the 4th one, of course, where it's fully autonomous, he calls it a taxi. You might as well call it a chauffeured vehicle, basically, with no human chauffeur. And there, the possibilities increase dramatically, particularly in terms of what happens on the supply side and how you buy mobility. And he likes to call it where essentially you buy mobility by the drink rather than by the bottle, because you're kind of paying for individual rides. Of course, that depends, because this is where a lot of the uncertainty resides today. If there are not going to be any more sort of regular suburban transit, for example, because that can very easily replace it with no driver issues, and that's what's partly complicating the whole adoption issues. What service models might emerge. Of course, autonomous vehicles are not new. We didn't invent that. There was a time, believe it or not, where GM was a very visionary company. And in 1939, at the New York World Fair, they actually had a model for an automated highway with automated vehicles where there would be abundant sunshine, fresh air, and fine green parkways upon which cars would drive themselves. So and they had a model of that on display at that exhibit. And it wasn't that long ago, this is in the late 50s, where the electric power industry was advertising for electric vehicles that would be driverless. And what you see in the middle there is where they're getting the power from. Okay, that's why they're driving on that line. And of course, the family is interacting in the vehicle that is driving itself. And this was an ad that the electric utility industry paid for to try and promote electric vehicles on highways. So anytime you sort of want to see the future and the past, what you have to do is look at the Jetsons. And you can find examples. First, he's still reading a paper. They didn't get that part. So yeah, the card playing, texting, whatever. But of course, that was then autonomous vehicles are here, and they are now, in many ways. Every major auto manufacturer, even GM, have examples that they're promoting to show that they have the technology. This is a sampling of companies with what they have on the demonstration side. So you recognize the brands here. every manufacturer has something that they're out there demonstrating. Okay. So if we look at the implications of vehicles, and I have these here slides only because sometimes when I'm presenting this to more general audiences, it's not safe, is it safe, and so on. And the safety, the safety argument is pretty simple, because if you look at what causes crashes, of course, drivers do, right? And the aspects of driving that lead to crashes typically have to do with recognition errors, decision error, performance errors, and so on, all the kinds of things that automation is intended to eliminate. So the safety argument is pretty clear as far as the value of automation. Now, one more thing, video that I want to show in the last one. This has to do now moving to connectivity. And so far we're looking at autonomous capability, but now when we move to connectivity, whether it's autonomous or not, that's a whole other element.
It wasn't long ago that the car revolutionized transportation. And now they're getting smarter through onboard technology and remote connectivity. Soon, they'll be expected to drive themselves.
My most recent research has been specifically on automotive applications. We do a series of applications on each individual application or application group, like emergency call or roadside assistance and so on, pay-as-you-drive insurance.
Today, we connect everything. Not only the car and the driver, but the whole transport ecosystem around them.
What's clear from that is that it is still very much fragmented, that each one of these things is delivered via their own service cloud, via their own back-end, their own aftermarket device. There isn't a common platform that's supporting all these services.
That's really the main point that I wanted to convey when it comes to connectivity, is the platform. And as the gentleman from, I believe it's Volvo, mentioned, there is not a common platform that is integrating these services. And that's what is important when it comes to achieving the benefits of connectivity. But if you look at connected vehicle technology and what it will buy us, it typically can help certainly in the typical driving decisions, whether it's lane changing, for instance, where you could see the ability then with information, the ability to accomplish these maneuvers more smoothly without leading to possibly shockwaves because the car behind you has to brake. And similarly, the ability to then pack the vehicles closer together and get essentially platooning, automated platooning, which then can raise capacity of existing infrastructure. So that's connectivity without necessarily having autonomous capabilities. And of course, Federal Highway Administration has been investing for many years in connected vehicle technology and concept and their applications in traffic flow, things like warning, speed harmonization, cooperative adaptive cruise control, and so on. But what's important to recognize, though, because often in discussion the two get mixed together. Okay, so what connectivity buys you, essentially, you can go from being isolated to receiving only, having peer-to-peer communication with your immediate neighbors, going to ad hoc networks, and then ultimately you get into the Internet of Things or Internet of Everything, where your car is connected to your dishwasher and so on. That's one dimension. And automation, on the other hand, as we discussed, you can start from level 0 to fully automated, which is level 4. Now, with more connectivity comes more capabilities, and so with some level of connectivity with almost no automation, you can get real-time information, you can track your assets, you can do things like electronic tolling, but then with more connectivity, you can start coordinating things like optimizing flow, routing, doing signs like speed harmonization, and ultimately to get cooperative driving, you need more and more vehicles to be connected, and that platform needs to be operating. And so if you look at where the intelligence lies, you're putting more system-level intelligence and interdependence as the vehicles are getting interconnected. Now, so to do that, there requires a lot of coordination among those who run the system, among the drivers themselves, the manufacturers, and so on. And for many years, at least since the early days of ITS, we've had this vision that you'll have these automated highways implemented in a variety of ways, but you're putting a lot of the intelligence to operate that in the system, not in the vehicle. And that has not quite happened the way we've all been discussing it. And instead, what we have seen, instead of the smart highways, entities like Google's have said, well, forget it, we're not going to keep waiting for all of that to happen. We're going to put the intelligence fully in the vehicle, okay? And so we're going to have the sensors on board that can recognize what's going on. We're going to put all of the intelligence entirely in the vehicle. And so that distinction is important. Now, many in the autonomous vehicle community say, but you can only do this if you have communication as well. And clearly, when you have information that is assisting you, then you're able to do this better. But the whole premise here has been, we can do it without waiting for all the DOTs to sort out their standards and for all the legal aspects to be resolved and so on. Because that is indeed, that common platform is not something that is that is trivial. Neither is, by the way, autonomous intelligence, but you're sort of much more in position there to start deploying. Of course, when you put the two together, then you get the kind of whole utopia of intersections without signals, because you're information. You're managing the intersection essentially by slowing some vehicles. This is a simulation by a colleague at Oak Ridge National Labs, and this is the standard thing that you will typically see with these intersections, of course, where the vehicle slows down just a little bit to allow enough of a gap, and the idea is that this will continue functioning with no need for anyone to stop, and so on. Now, you never see these simulations, of course, with higher volumes, right? Because if there are no gaps, somebody needs to stop, right? And so it's fine to show it at low density, but it does not quite scale up. But it's, it looks good. All right. So two sets of questions that I'm addressing here today. Adoption factors. So what factors affect the purchase and the use decisions of autonomous vehicles? Will people use them differently from conventional cars? Will new mobility service alternatives such as hybrid transit emerge in connection with these vehicles? And then how do we incorporate the implications of such adoption in our planning models? And then we ask, obviously, are current models adequate to consider these aspects? The answer is no. I mean, that's the easy, the simple answer, right? But we'll kind of go through some framework there. But the other set of questions have to do with traffic flow and system implications. Okay? What are the implications of connectivity and or automated functions, and how we model driver behavior in traffic? How do we then model the communication aspects? Because those are important as well, especially for the connected vehicle portion of it. And what are the implications of automation versus connectivity on traffic system performance in terms of safety, throughput, stability, flow breakdown, or that affects reliability, and then sustainability. And we've discussed safety already, so we're going to talk about throughput and stability primarily, as well as reliability. I'm not going to talk as much about sustainability today. And then, of course, we'll ask the question of what is the sensitivity then of relative market penetration on the impact of mixed traffic performance. So on the market adoption side, of course, you ask, well, who will buy? And then the question goes back to classic, Rogers adoption curve that generally has governed the adoption of smartphones, Fitbit, whatever, various types of devices. Will that apply to automated vehicles? And how is that going to be disrupted by the fact that, in fact, that you may have new types of mobility services that are emerging? Okay? So I have a very simple framework for adoption. Okay? which essentially consider four things. Consider the ability to drive, trust, the perception of benefit, that is the perception of the safety benefit, mobility benefit, and then the efficiency that might be introduced, time saving, constraint reduction, and of course there's affordability. Okay? So if you look at ability to drive as a function of age, right? We start with no ability when we're little, right? And then at some point you can drive, right? And you can pretty much, your ability remains pretty constant for a long period, and then it starts decreasing. You'll see as well, you need more glasses, get thicker, etc. And then at some point you really should not be driving anymore, right? So that's a very simple representation of ability to drive. And of course, there's also those who, as I said, cannot drive, who prefer not to drive, who prefer to drive, those who absolutely must drive because they really love to drive. And for that, there's BMW. Right? Now, if you look at the trust element, right? The trust element in terms of trusting technology, when we're little, we trust, right? I mean, little kids, they trust, right? They trust things, they trust technology, they're used to it. And that would last up to a point, and then you start getting skeptical. When you get older, eventually you just trust nothing and nobody, right? You question everything. So that's unfortunate because that's when you really need